I'm Paula Bierge, PhD student at Hospital Parc Taulí from Sabadell, Barcelona, and I'm going to present the results we have obtained so far in my thesis project in collaboration with researchers from the University of Porto, Portugal, and Hospital Clínic of Barcelona. We are studying Enterococci and their resistance to beta-lactam antibiotics, and more specifically, we have characterized Enterococcus faecium clinical strains causing bloodstream infections with atypical antibiotic resistance and virulence profiles. So, traditionally Enterococci were thought to be harmless commensal bacteria, even with benefits on certain gastrointestinal and systemic conditions. But when the relationship between the commensal bacterium and the host is broken, then Enterococci can cause very important invasive infections. So their robustness allows them to colonize very diverse environments such as food, feed, soil, water, and this ability to survive in adverse conditions makes them very dangerous when they colonize environments with selective pressure, such as hospitals, for example. So these with the malleability of their genomes to acquire resistances, either by the novel mutation or by the receipt of foreign genetic material through the transfer of transposons or plasmids, contribute to convert them into a leading clinical issue. Moreover, the antibiotics not appropriately covering Enterococci are frequently administered in suspected bloodstream infections, and this favored the emergence of resistances and infection dissemination. So, in most cases, isolates from hospital-acquired infections are ampicillin and vancomycin are resistant, enriched with certain virulent factors. And in addition, all literature to date describes faecium as intrinsically resistant to cephalosporins. But in Parc Taulí, we found that up to 23% of the bloodstream infections by faecium reported between 2011 and 2019 were associated with ampicillin and vancomycin susceptible isolates. And some of them were also susceptible to cephalosporins. So, a genome-wide characterization of representative faecium strains with a typical antibiotic-resistant and virulence profiles is reported in this work. So, we have characterized 7 faecium clinical strains isolated at Parc Taulí Hospital from elderly patients with bloodstream infections. One of them was isolated as single pathogen, and the rest were isolated with Klebsiella pneumoniae and or E. coli. So, whole genome sequencing using Illumina's NGS technology was performed to determine the genotypes of our faecium clinical strains, and comparative genomic studies have been undertaken to determine the causes of antibiotic resistance. So, only resistance genes to antibiotics often used in the animal production chain were detected, such as microlates and chloramphenicol. And despite being ampicillin susceptible, all isolates show PP5 variants accordant to a resistant phenotype. And these variants are commonly found in faecium from human surveillance, animal and environmental origins. And different virulence factors involved in adhesion, biofilm, pili, and or stress response were detected. But those commonly enriched in ampicillin and or vancomycin resistant isolates were absent. And the isolates were classified in the different strain types indicated in this table, and these strain types are commonly associated with livestock and human colonization. So just to conclude all these results, just to say that faecium clinical strains causing bloodstream infections exhibit molecular features commonly found in non-clinical strains, and the resistant genes and the strain types suggest the food chain as a significant source of these strains, or at least for the antibiotic-resistant genetic elements. but further studies are required to understand the reasons for these strains to invade humans and to cause infections. Thank you very much for your attention.